other mics on? They're on? Can everyone hear me? Okay. The talk is, can security detectors be hacked? And what are the capabilities of frequency devices? I call frequency devices what the government calls radio frequency weapons. So there's a little bit difference in the nomenclature. My cousin he was posthumously promoted to battalion chief. He was on the promotion list. And I started looking at, I've been in information security for 30 years, and I started looking more closely at what we expect our country to be doing. And part of it came about this talk. We're going to go through the electromagnetic spectrum, how waves propagate, millimeter wavelength X-ray backscatter. They just did a test with millimeter wave testing at the PATH trains. I have some documents here that I'll put up on the projector. We spent a lot of time on metal detectors. Metal detectors are a ubiquitous type of access device. And I'm going to show you that they can be hacked. You can create false positives. And in my demo, I'm going to demonstrate creating false positives and being able to, let's say, close down a courthouse or an airline terminal. I'm going to talk about front door and back door attacks. When people talk about radio frequency weapons or devices, they talk about front door, back door. Denial of service. I'm going to do the demo. Talk about the fog of a terrorist event. I was a survivor of the 1993 bombing of the World Trade Center. And the generals like to talk about the fog of war, but I've seen this fog in any type of terrorist event, and it seems to be the max amount of entropy. People don't know what to do, and they get wrong or misinformation. I'm going to talk about Carl Jung, the Swiss psychiatrist. Maybe there's insight in some work he did, why the FBI never was able to work on the information they received about the 9/11 attackers. Peak oil, King Rupert. He was a geophysicist in the 1950s who developed the theory of peak oil. Maybe there are things going about now that, because of peak oil, that terrorism is going to get much more intense in the next couple of years. Last, I'm going to talk about, I'm working on something, a laptop radio frequency device. Basically, can a personal electronic device be converted to create electromagnetic interference on an airplane to bring that airplane down? In other words, maybe the bomb of the future to bring down a commercial airplane is actually an electronic device. So let me start going ahead. The electromagnetic spectrum, 1 cycle to 1 billion cycles per second. It's an electronic wave and a magnetic wave, a changing electronic wave. Wave changing in time creates a magnetic wave changing in time creates an electrical wave. Microwaves are electromagnetic waves which have a higher frequency than radio waves. Infrared, even a higher frequency. Visible light, a higher frequency, and at the same time, as the frequency increases, the wavelength decreases. Ultraviolet, short, soft X-rays, again, higher frequency, shorter wavelength, X-rays, gamma rays. How electromagnetic waves propagate. They radiate in free space. There could actually be conduction. You can conduct radio frequency waves through copper tubing, copper wire, and generally you're talking about very low radio frequency waves in the 100 or 200 kilohertz range. Induction, magnetic component, magnetic coupling. You create a magnetic wave, can actually induce an electric current in a wire, magnetic coupling. X-ray backscatter and millimeter wavelength. And I said that they tested, they just tested in the PATH trains a millimeter wave backscatter. And what it does is it sees you through your clothing. Now, electromagnetic waves, not only you can produce them, your body actually produces them, mostly in the infrared and very, very short microwave wave category. This wave, this type of device can be either passive or active. It can either radiate millimeter wave radiation and direct it at you, or it can pick up the radiation from your body. When it picks up that radiation from your body, or is irradiated, or if you're irradiated with it, as I said, it's intrusive. It can pick up whether or not you have, let's say, an ostomy bag, or if you have, if you're a woman who had a breast removed and your breast prosthesis, anything underneath your clothes. Actually, what it's supposed to do is just pick up any type of contraband, whether you're wearing a, having a gun secreted in your clothing, or if you're wearing some type of a suicide bomber vest or something of that nature. Can it be defeated? In other words, is there some type of defense against this? And actually there is. Demonstration. I have two fabrics here, and both of these fabrics actually both absorb and reflect electromagnetic radiation. This one is a very high absorber reflector, and this one reacts with a metal detector. And at the end of the talk, if you want, come up. I'm going to leave both of these fabrics here for you to feel the texture. And these are fabrics that people use or wear or put in clothing, mainly because of the greater amount of electromagnetic pollution. Wi-Fi, Bluetooth, everything else. It's just a sea of electromagnetic pollution, and people want to keep it far away from their body as possible. This fabric doesn't shield as much, and it's more pliable to create clothing out of. This fabric won't react with a metal detector. I have a Garrett here, and I'm sure you've seen these in airports. And if I bring it over by the... So this will react with a metal detector pretty readily. This fabric won't. And you can also feel the texture of the fabric. In other countries, there's more of a concern about electromagnetic pollution than there is in the United States, especially about low-level magnetic fields. And these fabrics you can buy. I don't have a commercial interest in it. I'll have my email address at the end of the session. If you send me a little blurb, I'll send you where you can find the fabrics. So that's for backs. And this will take care of a X-ray backscatter, which is a very, very soft X-ray too, that will be reflected and absorbed off this. And as I said, this type of device is very intrusive. I'm going to get some more documentation or how Homeland Security wants to implement this. Right now they're just doing testing. I don't think they know if there are any countermeasures. I don't think they care. And I don't think they do a lot in terms of testing security devices. They test security devices, but they test them in the most favorable environment or under the most favorable circumstances. Metal detectors. They really came into their own during World War II to detect landmines, and they're used to sweep areas where landmines are. They're used even today for that purpose. You can't go into an airport or most buildings today without going through metal detectors. They have the walk-through variety. They have the handheld variety. What metal detectors do, at least not the treasure hunting metal detectors or the metal shooting, the coin shooting metal detectors, but the security metal detectors, one thing they do is they self-tune themselves. They're usually in a very hostile electromagnetic environment. That means that there's a lot of electrical equipment going on. There may be X-ray machines, microwaves, other things which they could pick up and they could go off on. So they have to be able to self-tune themselves. Some metal detectors, security metal detectors, don't self-tune. Some of them, they let you manually tune them. And that's a decision that whatever organization is buying them, whether or not to have self-tuned or manual tuning. One man's signal is always another man's electromagnetic pollution. Two metal detectors, or the walk-through variety, if they're in close proximity, they transmit a signal, generally under 100 kilohertz. That's 100,000 cycles. Some of them go up to 200 kilohertz. If you have two machines, it's the same machine, and they're transmitting at the same frequency, they would probably interfere with each other. Some of these machines, they have a digital signal processor in them. They can frequency hop. They can change frequencies so that they don't interfere with each other. Some of them frequency hop and also can self-tune themselves with a different frequency. And again, it depends on how smart they are. Usually at airports, you'll probably see the walk-through variety a number of feet apart so they don't interfere. There are two modes of operation for metal detectors. There's the motion mode and the pointer mode. The pointer mode means that it doesn't have to be in motion to detect metal. The motion mode means that it has to be on too. It has to be in motion to detect. Most of the metal detectors that you're going to come in security will be the motion mode ones. They won't be the pointer mode ones. The pointer mode ones, and if you want, I could do a little demonstration later on, you can actually shield things easily from a pointer mode one. Okay? What can you do to defend against metal detectors? You can shield and absorb the EMF field, create a false negative. You can increase the ambient background electromagnetic field, increase the electromagnetic pollution, which basically, on the self-tuning ones, they become less sensitive. They do detune themselves. To create false positive, you can broadcast on the frequency of the detector. You create false positives. And a false positive basically is a denial of service attack. Okay. With electromagnetic devices, weapons, there's a number of different attacks you can do. A front door attack, a back door attack, and if you do any searches on radio frequency weapons, they'll talk about this. There's actually a third coupling method too, which is actually coupling through the electric grid. In other words, if you compromise the electric grid and you inject your radio frequency signal right into the grid, you'll be able to create interference for that device, some type of interference. Front door attack is really something more for an urban terrorist. It's more surgical because you're doing front door attack through the antenna system and you're coupling through whatever frequency that machine is working at. So it's more surgical, it's more psychological, it gives you a much greater control ability, and also helps increase the bit error rate, which basically is if you have a device that, one second, just got up, I have very dry mouth. If you have a device that is performing some type of function with an internal signal, and now you inject a radio frequency signal near the frequency of that signal, it's also processing that signal, but that is actually an error. So if you increase the bit error rate to 100%, it's actually processing your signal and not the signal that it should be processing. And you can do that both with analog, sorry about this. You can do that both with analog chips and digital chips. For analog chips, the best way to couple your radio frequency energy is either creating a sine wave or maybe a sawtooth wave. With digital chips, obviously a pulse or a square wave. But again, depending upon what type of chip you want to go after, and most devices today contain both analog and digital chips, and depending upon which chip is closer to the front door and the antenna, that may be a way that you want to couple with that device. The next way is the back door. And the back door is basically creating a very large wideband signal in a short duration and really have an impulse of in the megawatt range. That is really something that is more left to the Army or the Air Force, because if you try to do it, which you may not be able to do, but even if you get close, you'll barbecue yourself. That type of effect, that type of using backdoor, that's basically the shotgun effect. You're affecting everything, and you may affect your own equipment too. So you may burn your own equipment up. Very, very high power. High infrared signature means some things are going to get really hot. You need a good delivery system. If your high energy electromagnetic pulse costs you, let's say $10,000 to build, you need a delivery system that is at least $1 million. You better make sure that when that goes off, that it's far, far, far away from you. It's not really something that's workable for an amateur to create or even a terrorist to create if you have a limited budget. The third method of coupling is to the electric grid, the electric power system. The electric power system could be the local building injecting signals right into the electric grid of the local building. It could be a bus, which I don't know why anybody would want to do the bus. It could be an airplane. Again, I'm going to talk about later on building an electronic device which couples to the electrical systems and autopilot in the airplane such that it can become the bomb of the future to take down an airplane. Or basically, I'm going to try to do the proof of concept, whether or not a terrorist or somebody else can do that. But again, coupling through the electric grid is probably the best way because you're funneling most of your energy directly to that device. And again, if you do any research on radio frequency weapons and the government, this is a booklet, and I'll talk about this more, that the government puts out for the threat of radio frequency weapons. They talk about these weapons are the thing of the future. They have to plan for them, that they're either here today or maybe within the next 5 to 10 years. They'll talk about just 2 coupling methods, but there are really 3 coupling methods. And I have a story about that pamphlet that may be more interesting. Okay. How can you do the denial of service attack with radio frequency devices? Well, you can use a technique of intermodulation, which basically your signal is mixing with the signal that the device is supposed to be receiving. You can overload the friendly receiver or device. In other words, put so much radio frequency energy there that it's just overflowing the front end and it's creating a problem. Today, we have more real-time processing using radio frequency links than ever before. And this can only increase over the next 5, 10 years. And it's going to be easy. Again, the protocols that they try to use for these radio frequency devices to transmit information, they try to do checksums and other authentication, but again, the denial of service is relatively easy, especially if it's some type of terrorist situation. Demo time. What I have here is, it's actually an audio generator from Ramsey Electronics. It's really audio and radio frequency. Goes 0 to 5 megahertz. Turn it on. I have a Garrett Super Wand. And Garrett, this is probably the best metal detector out there that I've ever played with or tested. And I think you see it ubiquitously all over the airports and everything. And it is the best. It's designed in such a way that you could do this all day long and not get fatigued. You know, there's nothing else more that I can say about it. It is the best. Garrett advertises that their metal detectors run at 95 kilohertz. Actually, a number of them I tested, and they run at a number of different frequencies, but in the 95 kilohertz range. This one runs at 94.1. Now, let me see something. Now, when this Ramsey generator, if I dial in 94 kilohertz, and this is a loop antenna. And just for this Garrett, I don't have, I have actually, this is not producing that much power, but I also have amplifiers, a number of amplifiers which work in the 100 kilohertz range where, gotta keep it plugged in, where I can put a higher power output for, let's say a conference room, if you're doing metal detecting, a courthouse. You can't get into a courthouse unless you go through a metal detector. a airline terminal. But basically, this is a denial of service attack, not against a server, but against physically having people go through these metal detectors to test it. Can you do to all these metal detectors? Yeah. Some of them require a lot more power, and I have a number of amplifiers that I have. And also this one, okay, I'm only about 3 or 4 inches close, but I have a couple of amplifiers where I can be farther away from the scarret. Just shut this off. Interestingly enough, there's... Good, where are they? Well, this is one of the amplifiers, and most of the time you're going to find audio amplifiers will actually work up far higher than 20 kilohertz, which is the highest level of sound. That's the highest frequency, which most people can hear. I can't hear that high. Okay, this device would work just as a demonstration, but is it scalable? How easily is it scalable? And it's actually very scalable. I have this is a kit. It's a 100 kilohertz frequency generator, and it also generates pulses, sawtooth waves, sine waves, square waves, and this runs on 12 volts. This is a 200 watt amplifier, and this will amplify this signal high enough that you could basically go against a conference room again, or a courthouse or whatever. The one problem, and this is backpackable. You could have it in your backpack. The only big problem is that you're going to need a lot of batteries. And yeah, really. To supply this, you really need at least 10 of these. Excuse me? 10 individual packs, yeah. 10 packs is about 16 pounds. Wait. This is about 4 ounces. This is about 4 ounces. One thing that they don't tell you, or the government won't tell you if they start looking at radio frequency weapons or devices, whether to take out infrastructure, is that you tend to, if it's portable, you tend to have a battery problem pretty quickly. The other problem you have pretty quickly is a heat problem. If I'm putting out 100 watts from this, these are actually pipe clamps, because this cooks pretty fast. There's actually a heat sink that goes with this, but I thought this is a better heat sink. These are actually just copper pipe clamps. This costs $25, and you build it in a kit. This amplifier, and this amplifier can actually can go up to a megahertz. It's just that the way it's wired, it only goes up to 100 kilohertz. And everything here just supports this individual chip as a function generator. Everything else is ancillary type devices. This is $35. So $35 and $25, $60. You throw in $40 of batteries. You want good batteries. You don't want these no-name brand batteries that I use. You want an alkaline or a very, very good battery if you want to have lingering power. $40. So for $100, you basically have a device to create a denial of service attack against a courthouse. And again, close down a small airline terminal. Again, the government does not worry about this or think about this. I doubt Homeland Security has any notion that something like this can be done, or some type of successful attack can be done, but it can be done. There's another thing that I just want to bring up, is that I'm using a loop as an antenna. Let me just bring this back up. This has like a high-speed toggle to get up to the frequency instead of just dialing it in. This loop is directional. Magnetic loops are directional. I don't know if we have any ham people in the audience, but this is the null. So in other words, this gives me a directional property that I could pick out a machine if I wanted to at an airport. At other frequencies, actually, something else I can do, and I've done it a couple of times, but not with great success. It's not 100% reproducible, is I can make a laptop reboot itself. I can't destroy the data that's there on a hard drive, whatever else, which some people on the internet would say that we can develop an electromagnetic device that can do that. I can't do that. The only thing I can do is I can make it reboot itself and sometimes loses data in its cache. But again, what's in the hard drive is still there, and you're dealing with a lot more power. But you can use this against at home. Okay. So that was for demo time. Let's go to something else. I survived the 1993 bombing. I'm sorry. I survived the 1993 bombing of the World Trade Center. I was on the 70th floor in 2 World Trade. And, you know, I was very scared. I don't know if you had too many people who have first-party type information what went on or what happened, but we felt a jolt in the building. And then we heard the sound. The sound takes a finite amount of time, 1,100 feet per second, so the sound wave took time to actually reach us. And we had no idea what it was. What happened is the lights went out very quickly, and all of a sudden, the 70th floor filled with smoke. And I have an autistic son, and you know, at that time I was just thinking about him because, you know, I thought I was going to die. What happened in buildings, the ventilating shafts for the elevators and the stairwells are supposed to be positively pressurized so smoke does not fill them. And all the power went out. The whole infrastructure went out. Now, in the World Trade Center, they have something known as the emergency notification system. People are supposed to come on loudspeakers, tell you what to do. That system was taken out. The smoke started getting so heavy that, well, first of all, in a fire, people die from smoke inhalation. They don't die of fire. But the smoke got so heavy that you could just feel the grit in your mouth and the grit in your teeth. And a couple of people tried to break out the windows, and they couldn't break out the windows. These windows are very difficult to break out. They threw like 90-pound pedestal tables at the windows, and they bounced off. And it wasn't until maybe over an hour into it that, even though the smoke was getting darker, it seemed like we could even try to go down the fire escape, the stairways. The phones did work. We got just very, very mixed information about what to do. Should we evacuate, not evacuate? Because you know that smoke's coming up through the stairwells. You don't know if the fire's on the 40th floor, if you're on the 60th floor or 70th floor. You don't know where the fire is. You don't know what's happening. Maybe you're going to be piled into a lump of people on a low floor and burned to death. Finally, and maybe about 90 minutes later, the smoke seemed to be coming up from the stairwells, did not seem to be as thick. And a bunch of us, you know, piled up. And at that time, I was creating, I did mainframe security. I still do mainframe security and other security. And I also had a laptop where I was creating mainframe IDs, going to be emergency IDs, so I knew I had to take my laptop. And I joined the procession down, walking down, and those stairwells are very narrow. It's only 2 by 2, total darkness. We had absolutely no idea what was going on. But again, it was the fog of this event, of what was going on. If in that truck that exploded, if there was some type of production of sarin gas or chlorine gas, and this went up to the floors, it would have killed us. Okay. Now, if you go to 9/11, something happened, a number of interesting things about the fog of a terrorist event. The first building, number 1 World Trade, was hit. And I still have friends in 2 World Trade on the 70th floor. The emergency, when that building was hit, 1 World Trade, the people in 2 World Trade were told, just stay where you are, everything's over, everything's fine, just keep working at your desk. We had some type of incident in 1 World Trade. And that was broadcast throughout the whole number 2 World Trade. Friends of mine that I had on the 70th floor, one woman saw a woman's body, not actually drop down, but seemed to float down, and she was on fire. It was like a wick. She couldn't believe it. And she just started screaming, and almost automatically everybody there got up and just left. I mean, everybody got up and left. I don't know what happened on other floors. You know, there are people, there are mothers, fathers, wives, that aren't here today because of what instructions they received there about staying in the building, don't go out. If I look at some other analogs to a tall building like the World Trade Center, I can see the same thing in the subway system or what happened bombings in subway systems, that if hypothetically there's a gas attack and even our emergency information is predicated on that you're going to get the first responders there very quickly. But if there's a gas attack in our subway, what happens if somebody uses a radio frequency device to play with the signals or the doors of the trains or even the communication systems, which are very vulnerable? Instead of having, let's say, 100 potential casualties, 100 people going to the hospital, it could be in tens of thousands if the first responders can't get to the people or the people can't get to the first responders. So the fog of a terrorist event is a very real phenomenon, and I just haven't heard anybody speak about it or mention anything about it. And I understand in the bombing in London, they had the same problem, and their radios wouldn't work in the subway, their communication systems. And communication systems, from all the experimentation that I've done, are very, very easy to take out. It does not take a lot of skill or knowledge. Chaos and not understanding what's going on, not having a full picture. Okay. This is a funny slide. Carl Jung never had a computer, never knew anything about radio frequency or anything else, and he probably didn't think about, I doubt he thought much about terrorist events. Carl Jung was the Swiss psychiatrist. He developed theories of personality and personality types. And Myers-Briggs, they were a mother-daughter psychologist team, and they developed a Myers-Briggs test. And they had that basically people take this test and you form one of 16 subtypes. And what is this used for? It's usually used for team building at corporations. You realize that people fall into one of 16 types, generally one of 4 quadrants, and you think or you perceive the world a certain way. And when they use this for team building at corporations, it's for people to realize the differences and how people can perceive problems and solutions differently. And optimally, if you put take a person from each of these quadrants, the way they think or perceive, put them together to solve a problem with a fixed number of resources, they can perform and get a more optimized solution to that problem. If you look at something like the FBI had a number of tip-offs about 9/11. They had this female agent who wrote about these people taking flying lessons of Middle Eastern descent. They had a number of walk-ins. They had information about the 21st hijacker, the agent who arrested the 21st hijacker. He also thought there was more going on, and the FBI never picked up on it. They never picked up on any of this information. And, say maybe the FBI needs to look at a different model. I don't know if anybody, Richard, listened to Steele, any of his conferences. And, I think he's 100% on the money about that. Okay. Now for something really upsetting. I sent away for this bulletin, radio frequency weapons. And, I read the bulletin, and most of it was cut and paste from the internet. And can you read that note, or you can't? Okay. Let me try to, I'll read it for you when I have an actual copy. No, I can't read from there either. Let me get, let's see if I can transfer this to, okay. blacked out everything that needed to be blacked. Hopefully everything. Can you read it now? And I wrote to this guy asking for this bulletin and said we will send a brochure to the above. Oh, sorry. Sorry about that. I'm giving a talk at the next Hackers on Planet Earth conference on the topic, can secure devices be hacked? I make use of radio frequency devices to defeat them. You and your organization might be interested in attending. And this guy works for the government. If you want to get this bulletin, you go out to www.tswg.gov. It's the Technical Support Working Group, which is supposed to support local governments, fight against terrorism. And this is what I got back. Paul, I'm not sure I could handle the repercussions of attending, let alone providing information that hackers find useful. I am, after all, from the Department of Defense. From the Department of Defense. I suspect my boss would have a hard time explaining that one to his chain of command. Thanks, but I'll have to decline. You know, I didn't set this guy up. I really did not expect this reaction. I don't know, maybe I'm very naive or stupid, but I just was very surprised. I'm not sure that our country, you know, people complain about the amount of information the National Security Agency is trying to gather and everything else, and I'm not even sure if they did get the right information, they'd be able to act correctly on it. I know about what happened with the FBI, and I was just totally blown away when I got this response. But, you know, I have the originals. Again, I didn't set the guy up, and, you know, I even have blacked out his name. I don't think, it's not that he should even be penalized or anything like that. It's just, it's more of an issue of the psychology or of that structure or that institution, that they haven't changed it, or they don't know how to change it, or they don't know how to react to information. So, one last slide. Two last slides. Sorry about that. Peak oil. I don't know if anybody's ever heard of King Hubert. You can do a search. Oh, switch back. Sorry about that. Okay. King Hubert was a geophysicist. I think he worked for Shell. And in the 50s, he worked out a mathematical model of peak oil. And basically, production and exploration will start declining. He did a prediction in 56 that production will peak in nearly 1970, that world oil will peak in the year 2000, 2010. And the major aquifer, or the major field that we get oil from, is called the Gawa field in Saudi Arabia, which is a monster field. It produces about 25% of the oil in Saudi Arabia. And that is well over 50 years old, which means that it's ready for the decline. With peak oil, I don't think things are going to become safer in the world. I think that the amount of terrorism or terrorist activity is going to increase dramatically, including in this country, like the guys that they got in Miami. I guess they're really wannabes, because I don't think they really could be a threat, but, you know, maybe I really don't know. But I think peak oil is going to be a major catalyst. Maybe it's the catalyst now, and things are only going to get much worse. But, you know, I don't see any bright side to this. Now the final slide. Can you build a radio frequency device into a working laptop? In other words, can this laptop be a device, an electronic device, that generates harmonics, frequencies, that will couple in such a way to an airplane, a jet airplane, passenger plane, that'll bring it down? And first of all, it'd be undetectable, because, you know, you bring your laptop through, they x-ray it to see if there's any organic matter in it. You know, there's just circuits and switchboards, which that's in any laptop. Um, it could be a very smart, warning 10 minutes. It could be a very smart device. In other words, you could program in, well, I want to create square waves at 1 gigahertz, or I could square waves at 10 megahertz. It could be a very dumb device that you just turn it on and it starts radiating. And with surface mount technology and the space in a laptop, it's relatively easy to do today. And I think this has got to be the first time anybody has ever heard of this type of device or thought. It may be, this type of device is maybe 5, 10 years away, but I think it's doable now. I don't know if such a device exists in the world. Well, let me put it this way. If such a device exists in the world, the people who have it, if they hear about this talk, would probably have to use it quickly, start using it quickly in the next couple of weeks before the TSA tries to develop some counter defenses against it. But knowing the way Homeland Security and TSA is, I don't think they can develop any counter defenses. I don't think they could. I think the FAA would be very concerned about this, but I don't think Homeland Security would find it as a threat or understand it. I'm sorry? Okay, okay. As far as I know, I'm the first person to have this type of idea, to actually do it. Airplanes are metal cavity. That means that the radio frequency waves bounce back and forth. Boeing, not Airbus. I'll tell you why Boeing, not Airbus. And Airbus seems to use a lot of composites, and some of the composites are carbon-based. They attenuate the radio waves. So it could also mean why we seem to have a little bit more problem on Boeing as opposed to Airbus. So I have to pick. It's not easy to take down an airplane. The FAA, NASA, they've done a fantastic job making airline security safe. It really is not easy. Airplane crashes happen because of outside statistical events. And basically what that means is if you drive your car, you run out of gas, you get out of your car, and you get hit by a car, another car, that's a statistically correlated event. Next time, you drive your car, you run out of gas, you get out of the car, you get hit by media, that's not a statistically correlated event. So a number of outside events have to happen. I got to get a jumbo jet with at least 15,000 cycles, takeoff and lands, because I need those cycles so there's more fraying of wiring and material in the plane. I actually have to pick my plane as carefully as I have to build my laptop and device. 100% certainty the laptop will pass airport security. This will go through security. There's no doubt in my mind this will go through. There's only a 10% certainty that it will cause a significant electromagnetic radiation problem in an airplane. When I build a device, I may not build the best device, only because I plan to use it for demonstrations. And I think there is a way to bring down airplanes and bring in the chances up to 90%, 99, 98%. But I think I'd be more comfortable just building a device that's not as good. Yes? Gut feeling. Gut feeling, yes. When they try to reproduce electromagnetic interference in airplanes, if an airplane has an event, many times it's hard to reproduce. Many, many times. And even people who do electromagnetic compatibility, these things are difficult to reproduce. So, you know, I'm dealing with a lot of things here, and I have to put a lot of things into basically a database. And basically, I reverse engineer everything NASA has done about interference in an airplane, and I do that. Okay. Any questions?
A small technical question. Can you tell us anything about sunspots and how they possibly affect some of this equipment? The other issue, and the bigger one, is at the end of World War II, when it, with the atomic bomb, after it first happened, there was lots of knowledge about it, and it was discussed, criticized, and everything. But within a year, there was this enormous secrecy, as if it was a secret and not science. Aren't we sort of faced with exactly the same thing today, and in a far more dangerous kind of situation, because people pretend somehow that all this is secret somehow or can be kept secret?
Right now, there are a lot of secrets, and you don't know what the government has done or is doing. I don't know. Maybe the government is working on something along the lines of what I've done. I really don't know. I know. But this is an application of technology. This is not pure science. I'm not doing pure science. I'm doing applied science.
You mentioned that this laptop EMF interference generator that you propose would pass an airline security check.
Yes.
What if the security required that the laptop still be functional?
It will function. It will go on. It will beep, beep. I'm sorry, I didn't make it clear that it's a working laptop. It will go on. It will be beep, beep.
And so
Because that's one of the first things they check for.
with the very small amount of free space generally available in a notebook, how do you propose to include all the amplification and the antennas required to generate significant EMF from a completely working notebook computer?
I don't have them here, but there's a surface-mounted technology that's very, very small. You realize your cell phones are getting smaller and smaller. Some laptops, there's a lot more room than others, but there is room there. I might put it in a separate battery pack bay. I'm not really sure. It's doable. It's doable. Whether it brings down an airplane, that's a question, but it is doable. It's doable today.
Thank you.
All right. I don't know how relevant this is, but do you think it would be possible to have a piece of, maybe lead, something that's going to block X-rays for if you have a suitcase and you're trying to bring it through the X-ray detector, to stamp an image in it or etch or something, what looks like an innocuous, what everybody would have in their bag, and have this in the lining, or in the upper lining of the bag, so that it blocks the X-rays in a way that would look normal, and then underneath the stamped pieces of lead, let's say, that are, look like, toothbrush or maybe some, a laptop or something. You have maybe something that you want to hide, and that way it can go through, it looks innocuous, they don't see anything funny, but in reality you have something mischievous underneath.
When I started this, I looked at different security detectors and tried to develop different scenarios for each of them, and that's the exact scenario that I thought of for X-ray. Basically, you develop some type of grid or matrix of absorbing metal, radiation-absorbing metal, and basically it looks like almost white noise. And I think you would be able to get it in very easily, whatever you're trying to put through.
Okay. Do you
So I
think
think you're on the right track, which probably means that other people are trying to do it.
But do you think it would be possible? Because I think if what they would, if they saw something funny on the screen, if it was like noise where they saw, it was scattered and they could see nothing, then they would open up the bag and look inside. I'm talking about maybe like drawing what it would look like if there was normal things that a person going on vacation would have in a bag, stamp that design out of lead, and put it in so it looks like normal stuff in the bag, and then you have underneath nasty things or whatever.
That's good. That's even better than what I thought of, because that looks even better than something that's more white noise. I think you got a better idea. Maybe next time you'll try to do that for next Hope number 7. But that is a good idea, and I doubt that Homeland Security, these other people, have thought about it or considered it.
Okay, quick question. You did not Airbus. Now, most Airbus planes are fly-by-wire. Now, I don't know if that actually means wire or if that's actually fiber optic. If it's actually wire, it would seem that might be more susceptible to an attack, because that might pick up signals and it might jam the computers.
You're
and
right.
might cause issues.
You're right. But the Boeings are fly-by-wire too now.
Oh, are they?
It's just that the Airbus, I have to give a gut instinct about what thing, because they're not letting me close to their airplanes. I'm going through, they're not going to let me maybe in the airport anymore. I don't know. I have no idea. Yeah. I'm just saying that because of the composites, they would tend to absorb more of the radio frequency energy.
Probably.
But I could try it with Airbus too. I'm just trying to say which airplane do I have my best shot with, since both of them are generally fly-by-wire? I think Boeing.
As far as the equipment would actually go, probably, since a notebook battery is fairly high power
Yeah.
anyway, if you use a super cap along with it, you're making very high level pulses with with a low duration. You wouldn't need high power or large equipment because you wouldn't have a high duty cycle to overheat or anything else. They could be quite small, and I think you could end up with easily, you could probably get 200 watts in short pulses out of a notebook battery for
Well,
quite
I
a while.
figured that what I needed to produce is about 10 to 20 watts of RF power.
You could probably get a lot more than that in short pulses. With
Yeah.
a low duty cycle, it would probably do more damage.
Yeah.
It would block better. And the battery in a notebook is quite capable of doing this. Think
Yeah,
about the current rating on
the
a notebook
lithium ions
battery.
are very powerful today.
Look at those freaking batteries. There's a
Yeah.
lot of power in those damn things.
See, the trouble is, they're not going to let me close to an airplane,
That's for sure.
especially, although I doubt that, I really doubt that Homeland Security or those other people have stopped.
I mean, it is a scary thought. And I think it's quite doable, to be
Yeah.
honest with you.
It is,
I think 10% is way too low a guess, I'll be honest with you.
I'm going to work on it. They told me to stop. Sorry about that.